3.8, number 304. We have xy minus cos of xy equals 1. We're supposed to find dy dx. dy dx is the standard derivative in the plane. Standard slope of the tangent line to this very complicated curve. All right? So the notation here is important. It's telling you to use this operation, the d dx operator, okay, which could be, in these problems, different now. It could be dx dy we're trying to find, therefore I would use d dy. It could be dx dt, dy dt. You can introduce new variables even if they're not in the equation itself. So writing it in this way and looking at the question carefully to see which derivative operation to use is important now, unlike before when that was never really an issue. Nevertheless, we're supposed to apply d dx to both sides of this equation. The derivative of this side should equal the derivative of this side because the original two expressions were equal. So their slope should be equal. The right-hand side is pretty obvious. It's 0, of course. The left-hand side is more subtle because of the combinations of x and y in here. Again, when you're dealing with implicit differentiation, y is somehow a function of x. Okay? Y is implicitly a function of x. It's no longer just a variable. Like x here is just a variable. So the derivative encounters the subtraction here, the difference going on between these two. So therefore the difference rule is applied first, and this derivative distributes across here to both of these terms. When it encounters this one, it's encountering a product of two functions. One a very simple first power x function, and the other one is the function y. The function y, I don't know what it looks like, but I know that y is dependent upon x, and so how I treat y in here is now different than just being a regular variable. So anyways, it's a product rule at this point, so I have the first function, x, times the derivative of the second function. So that's not the number 1. I'm not taking the derivative of x with respect to x. I'm taking the derivative of y with respect to x. So it's the set of symbols dy dx plus, as part of the product rule, right? First derivative second plus second times the derivative of first. This is 1. Right? The derivative of the variable x with respect to x is, of course, 1. So there's our product rule completed, and now we need to deal with the derivative of cos xy. So minus, new derivative. So here the most outer thing happening is the composition of this cos function with xy. So therefore the outer function is cos, and its derivative will be negative sine. Inner function xy stays the same. Now I need to multiply by derivative of the inner function xy. Now in this case, I already know what that is. We just had it over here. So I'm going to rewrite this x dy dx, and go ahead and take that derivative right now. Plus y times 1. Right? So there is the cos xy derivative taken, and this all equals 0, of course, because we have the derivative of constant on the right-hand side. All right, now we just need to solve for dy dx in this. So I will distribute the sine xy across this sum here, so that I can gather the dy dx terms on one side and all other terms on the other side. So we'll have x dy dx plus y. These two negations make it positive, and then sine xy times this will be written better as x sine xy dy dx. It's customary to write the derivative part of the term as the last. and then plus y sine xy. That's all equal to 0. So I need to get these two together, and I need to get these two together on the other side. So we should have something like x dy dx plus x sine xy dy dx equal to these two negated on the other side. So negative y minus y sine of xy. Okay, so now it's just a matter of factoring off dy dx from the left-hand side here. So we get dy dx, the object we're searching for, we factored off of here. X can also be factored off. I'm not going to do it right this moment. I will in a moment. Sine xy there, a little sloppy. All right. I have that. Now the problem's basically done. So now we just divide off by x plus x sine xy, and then factor it just to make everything look a little bit neater. So finishing up, it'll look like this: dy dx equals negative y 1 plus sine xy, and down here we'll have x 1 plus sine xy. So ultimately they cancel, and we get negative y on x in this case.